10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff.
Gravity is a familiar concept. It is created by all matter. We can calculate its intensity easily when the number of objects is small, and gravity applies forces to all matter in a reciprocal way. Gravity gives every movement, every activity, a typical and normal look. When gravity is absent, like in space and far away from any planet or star, or when gravity is not felt due to special conditions, like in the International Space Station orbiting around Earth, the movements of people and objects are very different. They have a magical touch. If there is no gravity and no other forces, the principle of inertia applies. This principle is described by Newton in the first law of motion, which says an object not incurring any external force is moving at constant motion. This means that such an object keeps moving in the same way, including any rotation it may have. Now, if we want to experiment zero-G, we may want to look for a place with no gravity. But this is impossible, as the reach of gravity is infinite. And anyway, we do not have a rocket to escape from only Earth. But we can create a situation of zero gravity by applying the equivalence principle of Albert Einstein. This principle says that there is a complete physical equivalence between a gravitational field and an accelerated reference system. So, if a reference system, like a box, is accelerating at a rate equal to the value of the gravitational field created by Earth, then objects considered locally in this system will not incur any force. Said differently, and more simply, when you are in free fall, you don't feel gravity, you are basically following it. This is why zero-G experiments are sometimes done in a falling plane, the Airbus A310 proposed by Air Zero-G. This plane goes up very fast, then reduces the engines and follows a free fall curve for 22 seconds before starting again the cycle. So the idea for our experiment is to throw a box in the air with objects and a camera inside and see what happens. Then the question is, how much time of zero-G can we get? We can calculate the time it takes for an object to fall freely from a specific height. We know that speed is increasing linearly in a free fall. Every second, the speed increases by 9.8 meters per second. Speed can also be calculated as the variation of position divided by the variation of time. So we can integrate and find the position as a function of time. So we can get the time it takes to fall from a specific height. It is interesting to see that to get any significant duration, like 3 or 4 seconds, we need to let the object fall from very high. And the issue then is that air resistance will ruin the experiment. So to overcome these challenges and still get a nice experiment, we will throw the box upwards for about 2 meters, so we get 0.6 seconds, and the box will fall back down 5 meters for another 1 second of free fall before reaching the ground. In total, 1.6 seconds seems like not a lot, but using high frame rate and slow motion, we can get 10 to 20 seconds for each throw, which is more than enough to see what's going on. Okay, enough theory and explanations. Here is our 0G box. Let's warm up and throw it up in the air. I hope you enjoyed this video, which was quite a lot of work, but also a lot of fun. Please subscribe, make sure you click the thumbs up, and hit the bell so you get notified on the next videos. Bye for now.